Welcome back to Learn Physics Mathematician. In this video, we will see MCQs from vector algebra. The first question, the magnitude of vector 6i minus 2j plus 3k is. A vector is given, we need to find its magnitude. Okay. So usually we find the magnitude by squaring the component of the I, j and k. And then we have to add them together. Okay. So we will get 6 square and minus 2 square and 3 square. So 36 plus 4 plus 9, and this will be equal to 49. So it is 7. Option C. One thing you have to be careful, even if you have a negative number, it will become positive when it is squared. So all the terms under the root are always positive. Question number 2. A plus b equal to I vector. A vector is equal to 2i, 2j, 2k is given. We need to find the magnitude of b vector. Okay. To find the magnitude, first we have to find the b vector and then we will find the magnitude. Okay, so I'm taking this equation, a vector plus b vector equal to I cap. Okay, so in this I have to find the b vector, so I'm taking the a to the right side, so I will get I cap minus a vector. The value of a is given in the question. I'm just replacing it with the a, 2i minus 2j plus 2k. Okay, and we can take this negative sign inside this bracket, so we will get minus 2i plus 2j minus 2kk. Okay, now we can combine the two items, so we'll get minus I plus 2j minus 2k. So this is the required b vector, and we need to find the magnitude of this b vector, so we will get minus 1 square plus 2 square again minus 2 square. So the result will be 1 plus 4 plus 4, we will get root 9. Its value is 3. So option B. Question number 3. There is a triangle, it is called ABC. In that AB vector is given, AC vector is given, and D is the midpoint of BC, and we need to find the AD. Okay. So I'm drawing the triangle like this. This is ABC, and AB vector is given, AC vector is also given. There is a point which lies in the midpoint of line connecting B and C. Now we have to find the vector AD vector. Okay, to find the AD vector, we just have to add the AB and AC together, and then we need to divide that with 2. Okay, so that's it. So AB vector is I plus j plus 2k, and AC vector, that is 3i minus j plus 4k. Okay, this needs to be divided with 2. On simplification, so I plus 3i will become 4i, and j minus j will become 0, and 2k plus 4k will become 6k, that will be divided by 2. Now we have to divide each term with 2. 4i divided by 2 is 2i, 0 by 2 is a 0, we can leave that, and 6k by 2 will become 3k. So the option is D. Question number 4. ABCD is a rhombus whose diagonals intersect at E. So first we have to draw a rhombus. This is A, B, C and D. The naming should be done either in clockwise direction or counterclockwise direction. So in this case I have taken clockwise, and the diagonals of the rhombus intersect at point E. So I'm going to draw the diagonal. This is a diagonal 1 and this is a diagonal 2. They intersect at point E, and we have vectors EA vector, which means it starts from E and moves towards E. So we have to mark that vector like this in upward direction. And EB vector, it starts from E and moves towards B, and EC the same thing, it starts from E and moves towards C, and ED which moves in leftward direction towards the left side. Okay, now we know that the diagonals of the rhombus bisect each other. Okay, which means the length from the midpoint to either end of the diagonal is always same. The value of EB is exactly equal to ED. Okay, because the point E is in the midpoint of diagonal, so EB value is exactly equal to ED. When we convert this into a vector form, we have to add a negative sign in front of this. because the direction of EB is towards right side, but ED is towards left side. Okay, so we have to put a negative sign. In the same way, we have one more diagonal, that is AC diagonal. Okay, so that can be written as the length of E to A is exactly equal to length of E to C. Okay, so both lies in the same line, and E is the midpoint of AC, so we can write like this. Okay, but when we convert this into a vector form, EA is acting in upward direction, but EC is moving in downward direction, so we need to put a negative sign here. Okay, so this is what we can conclude from the given information. Okay, now we have to find the value of the equation given in the question. Okay, so we can write EA vector plus EB vector, EC vector plus ED vector. So we need to solve this equation and find the value. Okay, so first instead of this EA we can write minus EC. So EC vector plus, we can keep instead of this EB we can write minus ED. So minus ED vector, we can keep the last two terms as it is. Okay, so as you can see, we have minus EC vector and plus EC vector, and similarly we have a negative ED vector and positive ED vector, so all the terms will get cancelled. The result is 0. Option A. Question number 5. Two vectors are given, A vector and B vector. So in this case, we have to find the condition which makes the both vectors into a collinear one. Okay, the required condition is the scalar components should be proportional to each other. Okay, if they are proportional, then the two vectors are said to be collinear or parallel. Okay, so in this case, the I component is A1. In the second vector, I component is B1. Similarly, the J component is A2 by B2, and the ratio of K component is A3 by B3. If these three values are exactly equal to each other, then the given two vectors are parallel or collinear to each other. So the option is B. Question number 6. We need to find the unit vector along the given vector. Okay, so I'm taking the given vector as A vector. So 4i minus 3k cap is given. So to find the unit vector, we have to divide the A vector with its own magnitude. So this is the formula for unit vector. Whenever we need to find a unit vector for a given vector, we have to divide the actual vector with its own magnitude. So the actual vector is 4i minus 3j, and its magnitude is given by, we can square the component of I, as we have seen in the first question. We can square the component of I, that is 4 square, and j component is 3, so 3 square. So we will get 4i minus 3j divided by 16 plus 9, we will get 25. This will be equal to 1 by 5 times of 4i minus 3j cap. That's the required answer. This is an option B. Question number 7. Unit vector along PQ where the coordinates of P and Q are given. In this case, 2 points are given. The first point is P and second point is Q, and we need to find a vector along this direction, and then we can find the unit vector. Okay, so first we have to find the PQ vector. PQ vector is nothing but x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. You can substitute the value. So the x1 y1 z1 value should be taken from the initial point, and the x2 y2 z2 can be taken from the terminal point. Okay, so I'm using 4 minus 2 I cap and 4 minus 1 j cap, and the z value is minus 7 minus of minus 1 k cap. 4 minus 2 was 2 I cap plus 3 j cap, and the last term should be minus 7 plus 1 minus 6 k cap. So this is the actual PQ vector, and we need to find the unit vector along this direction. So I'm naming that as PQ cap. To find the unit vector, we have to divide the PQ vector with its own magnitude. I'm rewriting the vector here, 2y plus 3j minus 6k cap, and its magnitude is given by 2 square plus 3 square minus 6 square. So we will get 2y plus 3j minus 6k cap divided by root 4 plus 9 plus 36, so which is 49. So we will get 2y plus 3j minus 6k divided by 7. So this is an option D. In this question, you have to be careful. The vector is along the direction P to Q, which means the vector starts from P and moves towards Q. If you solve this using Q to P, and then you will end up in the result C. Okay, so your answer will be wrong. So you have to be careful. Question number 8. If a vector makes an angle of pi by 4 with positive directions of both x and y axis, then the angle which it makes with positive z axis is. In this case, the angle made by the vector with the x axis is given, that is pi by 4, and angle made by the vector with the y-axis given, that is also pi by 4. Both values are pi by 4, and we need to find the angle made by the vector with the z-axis, that is gamma. We have to find. Okay, so alpha is the angle between the vector and the x-axis, beta is the angle between the given vector and y-axis, gamma is the angle between the vector and z-axis. These two values are given, and we need to find the third one. Okay, I'm going to use the property of direction cosine, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, so cos square alpha, that is cos square of pi by 4 plus cos square pi by 4 again plus cos square gamma is equal to 1. We know that cos pi by 4 value is 1 by root 2. If it is square, it will become 1 by 2. The same 1 by 2 we will get here, and cos square gamma is equal to 1. We can add them together. 1 by 2 plus 1 by 2 is 1, and cos square gamma is equal to 1. Now we can bring the 1 to this side, so we will get cos square gamma is equal to 1 minus 1, that is 0. Okay, so cos square gamma value is 0. If you take square root on both sides, we will get cos gamma equal to 0. Okay, so we need to find the value of gamma for which the cos term is 0, that is pi by 2. Okay, cos 90 is 0, so the gamma value should be equal to pi by 2, option C. Point R divides PQ in the ratio 3 is to 1. S is the midpoint of PR, and position vector of S we have to find. In this case, we have to use the section formula, internal division. Let me draw the lines. This is P vector and this is Q vector. Okay, and these two are points P and Q, and one more point is given, that is point R, which divides the PQ in the ratio 3 is to 1, which means the PR part is 3 unit and RQ part is 1 unit. Okay, so first we have to find the R vector, and then we can use this data to find the S vector. Okay, first we have to find the R vector. To do that, we have to use the section formula. R vector is given by P vector into 1, that is the given ratio, and Q vector into 3 divided by 1 plus 3. We have to add the ratio, so we will get P vector plus 3Q vector divided by 4. So this is the R vector. Now we have to find the position vector of S, and the S is the midpoint of PR. That's also given in the question. I'm going to make one more diagram with this P, and this part is R. S lies in between them. We know the P vector and R vector. With this data, we have to find the S vector. Okay, actually S lies in the midpoint of P and R, so we can directly add the P vector and R vector and divide the result with the 2. We will get the S vector. So S vector is equal to P vector plus R vector divided by 2. Because S is the midpoint, I'm going to replace this with R vector. So P vector 3Q vector divided by 4 divided by again 2. Okay, so just doing some cross multiplication, we will get the result like this: 4P vector plus P vector plus 3Q vector divided by 4 into 2. So we will get 5P vector plus 3Q vector divided by 8. Okay, this is the required result. This is an option D. Question number 10. Midpoint of AB is 3i plus 2j minus 3k, and A vector is given, and we need to find the B vector. As we have seen earlier, position vector of midpoint is given by sum of the two vectors, that is A vector plus B vector divided by 2. Okay, position vector of the midpoint is given, and one of the two vectors is given, and we need to find the another vector. Okay, let's put the value here: 3i plus 2j minus 3k is equal to A vector, that is 2i plus 3j minus 4k plus B vector divided by 2. Now we can rearrange this. I'm bringing this 2 to this side, so we will get 6i plus 4j minus 6k is equal to 2y plus 3j minus 4k plus b vector. Okay, I just multiplied the two. Now we can bring all the terms to this side, so we will get 6i plus 4j minus 6k minus 2y minus 3j and plus 4k equal to b vector. So all the terms on the right side are brought to the left, so we will be left with b on the right side. Okay, now we can further simplify this. 6i minus 2y is 4i, and 4j minus 3j is j. Okay, and minus 6k plus 4k will give minus 2k. So 4i plus j minus 2k. This is an option B. So that's it for today. We will meet in another video with little bit harder questions.